Python data types, experiment 3. This is a complex type discussion. So in this session, we will be dealing with complex type data type in Python. We already discussed about the numeric types. Under the numeric types, we have int, float, and complex. I believe you people would have understood how int data type is used in Python and how float data types are used in Python. We saw an extensive discussion on both the types. Now it's a time to discuss about the complex type. Complex type also comes under the family of numeric type. Now how the complex type data type is going to be represented? How we represent a value in complex data type. If you look at this, a template, I have a template here. You can just have a look at it. And this template says that it contains a real part. It's a template for complex data type, and it contains real part plus imaginary part. Combining the real part and imaginary part is what we call it as a complex data type as. So technically speaking, how do we represent this in a Python code? How do we talk about the real part and the imaginary part in a Python code? We'll see that shortly. Now, if I want to represent a simple complex type, let's declare a variable like x equals, I can denote a value called 3. It's well known that this is a decimal value, and this decimal value is 3, and that's been stored in a variable called x. If you trace out for the data type of this x, you can notice that it's nothing but an int. And this type is an integer type falling under the category called numeric types. But this doesn't denote a complex type. So how a complex type would look like? I have a real part here. This 3 represents your real part. Okay, a real number or real part. And you will co-join with an imaginary part, and the imaginary part will be represented with a notation called j. You will have a number followed with a notation symbol called j. So let's take an example, 2j. The 2j represents an imaginary part. So you have a real part, you have an imaginary part, combined together you represent it in x. Let's comment out this print statement. This seems to be little trivial to understand because 3 plus 2j, do you mean to say you're talking about a j as a variable here which is multiplied with 2? Relatively not, because j is only a notation to represent that it is an imaginary part. But coming to the execution of this code, the interpreter is not complaining anything about this statement. The reason is the interpreter can understand that this x is holding a complex type of value. So inbuilt to the interpreter, these type of values will be categorized into a complex type. And again, the complex type comes under the family of numeric. Now, if I try to trace out the type of this x, you will notice that it represents a class called complex. Before we saw it was representing an int, and now it's all about the complex. So what a complex value look like? A real part combined with an imaginary part. And how you represent an imaginary part in Python? By having a notation symbol called j. J represents an imaginary. But what if I want to multiply j with 2 where j is really a variable in it? Of course you can do that, but that need to be done with a multiplication symbol. And that denotes that it's going to be multiplied with a variable called j. And obviously now this is not going to be treated as an complex type because you are doing a mathematical operation combined with a value and a variable. So this is indeed going to end up with an integer or a float based on the value that you're going to store in the variable called j. And if we go ahead and execute this, you can see that it is int. So it is not a complex type. It is not considered to be a complex type, right? So how a complex type looks like is you have a real part combined with an imaginary part, and always your imaginary part will go with a notation of j. You should have noticed this kind of an expression in mathematics. In many of the mathematics statements, you would have come across these kind of an expressions, and there we denote it as a complex type. But what if in case if I reverse this expression, let's say 2j plus 3. If I do this way, is that going to be considered as a 2j plus 3? Still it's going to be a complex type, but we need to print that x and see how it's going to be evaluated. So let's go ahead and print the variable x. You can see now it is still considered as a 3 plus 2j. So always from the operation of plus, if you see on the left hand side, you only have your real part, and post that you have your imaginary part. If I'm going to try out with a negative number, then it's going to be of minus 3 plus 2j. Okay. If it's going to be of multiplication, it's going to be of 6j. So it is exactly multiplied and then it produces a complex type. Okay. So plus and minus would be more sufficient to understand these standards of complex values. But at the end, what you can notice here is a complex type is none other than a real part plus an imaginary part. That's great. Now let's go more in detail about how we can manipulate this complex value when we have more complex expressions, so that you will get some idea of how the complex data types are actually utilized in Python. So now I'm going to carry some set of functionalities to resemble a complex type. So let's take an example like this. I have a function called complex to denote a complex value. You can straight away refer your complex value like this, or you can use a complex function to represent a complex value. That in turn represents a complex type. So complex function is an inbuilt function. You have an inbuilt function in the Python, and that is called as a complex, and this helps you to convert your given value into a complex value. So how we can do this? Let's declare a variable called u. The first variable which I have is a u, and this u is going to carry a complex value in it, but interpreted with a function called complex. So I'm going to declare 2 comma minus 1. So if you notice this, I'm representing a couple of parameters to this complex function. The one we talked about the real part, and the 2 we talked about the imaginary part. The second one is all about the imaginary part. So if you try to trace out this u type, and if you try to print the value of that u, you can notice that it all falls under the category of your complex value and a complex type. Great. So the first parameter is none other than a real part. Since you have a minus representation there, it takes minus 1j. But if in case I don't represent any of the imaginary part, then it's going to be considered as 0 by default. So the rule is applied like this. Real part, if real part is omitted in the complex function, it defaults to 0. And an imaginary part parameter, if imaginary parameter is omitted, it defaults it to 0. And that's what is happening ideally here. So how do we take out a real part as a default to 0? Let's denote j and see what's going to happen. So it's 0, so they didn't consider it to be an expression, and overall they produce the output as 2j. But if I come up with any other notation like I, or let's say k or something like that, then obviously you will end up with an syntactical error, because the notation for complex value, and that too exclusively for an imaginary part of a value, you need to go ahead with a notation called j. So by this way, you get the exact expression of complex and followed with your the type of complex. Now coming to further discussion on this, we can declare one more variable like v, and then denote it as a complex and represent a value like 1. So here in this case, obviously we don't have an imaginary part, so it need to be considered to be a default to 0. Let's go ahead and print v. I don't want to find the type because we are well aware of what those types are going to be. So we have 1 plus 0j, that's all about your v value, and complex type value of u is 2j. So let's go ahead and give a earlier value like -1, and now you get this output like this. So the idea here is we are trying to manipulate the complex values. So to be more precise about the statements, don't refer this j or the notation, because complex method will automatically consider it to the imaginary part. So you just mention 2 comma -1 and then v is 1. You just execute this, you get the output. Now what I'm going to do is I'm going to add a couple of expressions like z equals u plus v. So when I say u plus v, so let's print it more in an ordered way so that you will see the output of z will be of manipulated value of u and v. That's all. The manipulation is all about the addition. So let's try to print z. Now what you get here is u is 2 minus 1j and v is all about 1 plus 0j, and when you add both the complex expression of values, you get 3 minus 1j. So if you look at these expressions, the output is 3 minus 1j. It's more known expression, right? We ourselves can self-understand that how this addition is going to happen. But what I'm trying to conclude here is the complex values are going to help you out in managing your complex expressions. And you can use exclusively a function called complex in order to manipulate it, right? And this complex function is going to take the default values as well whenever if you are not representing them. So it takes the exact default value of 0 if in case imaginary is omitted, or a 0 for real is when real is omitted. Not only that, we can also do this way. Let's say I have another variable called e, and that I'm going to use with the final outcome of z plus a real number like 4.5. And if I try to print this e, you can notice that it prints 7.5 minus 1j. So what it does with it, it just adds the real number into your real part. So it's z plus 4.5 reflects your 7.5 minus 1j. If in case I'm representing it as a imaginary value, you can see that it's 3 plus 3.5j. Why? Because you have -1 and plus 4.5j is representing it as a plus 3.5. So obviously the way it works is all about a complex expressions. So that's why Python is dedicating a particular data type called complex data type. So with this complex data type, you can do more practical coding whenever you fall under an applications like machine learning or data science. Then sure, you will be dealing with these kind of a complex types. Imagine if we don't have any complex type at all, then we have to custom design a complex type, and that's going to be very tedious to create a custom complex type. So we need to appreciate Python that it has come up with defining a complex data type under the family of numeric, so that we can make use of the functionality effectively in a higher end applications like data science or machine learning.